Hi, in this video, I'm going to explain how to construct a square root spiral. Okay, so this activity helps you visualize irrational numbers in a better way. So let me get straight into it. So first you have to draw. So what we will basically be doing in this activity is that we will be drawing right angled triangles. Okay, so this is like a combination of right angled triangles uh, in such a way that they give you a spiral. Okay, so let's start with a point somewhere on the board, and let's name it O. Then you have to draw a line segment. Let's call it OA1. Okay, now first of all you need to remember that this line segment is of unit length. Length of this side must be 1 unit, and you can take like 1 centimeters, 1 decimeters, or you can also say that 2 centimeters on a scale on a ruler is equivalent to 1 unit on this board or on in this activity. Now what you have to do is that then you draw another line segment which is perpendicular to the previous one. So this line segment, let's call it A1, A2, and this is perpendicular to OA1, right? So, and this is also of unit length. Now you will see that what are we going to do here is that we are trying to make a right angle triangle, and then we join OA2 to get hypotenuse of this triangle. Now you know that this hypotenuse measures the square root of 2 in length. Why so? Because we have used here effectively the Pythagoras theorem, which you are familiar with. Now taking this hypotenuse as a base, we will draw another line segment of unit length perpendicular to it. Okay, and this is of unit length as well. Why so? Because this side is of square root of 2 unit length and this is of 1 unit length. So what we will get is this side, this hypotenuse, which measures square root of 3, right? So again, in this manner, we will draw a line segment perpendicular to, let's call it A3. So this was A1, A2, A3. Look at the pattern. And then we will join this to the originating or to the starting point. Okay? And this is also, we need to remember that each line segment of unit length will be perpendicular to the previous hypotenuse. And let's call it A4, right? And this will be, as you can see, of square root of 4 length. Okay, and square root of 4 is basically 2. So this is not irrational, this is a rational number. And then you do it again as before. So you draw another line segment perpendicular to OA4 and call it A4, A5, and this is also of unit length. And then you get this hypotenuse which measures square root of 5. And this is irrational, okay? This is irrational, this is irrational, and this one is also irrational, okay? And again, taking this hypotenuse as a base, we are going to draw a line segment perpendicular to OA5, okay? So like this. So this is not exactly perpendicular, but because I'm drawing this on a board, but you get the idea what we are up to, right? So this is A5 and let's name it A6, and then join A6 in this point A6 to O, the starting point. Okay, now this is of length square root of 6, right? So let me draw some more hypotenuses. Then we draw another perpendicular line segment, join it, call it a 7. Yeah, so these all are of unit length. All the bases, all these upper line segments are of unit length. And call it A8, A sub 8, join it with O, and you get the square root of 8. Okay, so it kind of went like a curve. I tried to make it a straight line, but okay, problem. A9, and this is the square root of 9, which is, so the square root of 4 is 2, the square root of 9 is 3. So these two, as we can see, are not irrationals, okay? Then we have another one like this. So I will have to erase it and adjust. Yeah, so it will be square root of 10. So continuing in the same manner, we will be like we will get a better, since I'm running out of space here, but you can make it, you can draw further. So you'll have to take a large sheet of paper to get this beautiful spiral on it, okay? So let me explain it, what's going on. As you can see that we started with square root of 2 as our first irrational number, okay? And then as we progress, we are basically taking or getting a square root of the next consecutive positive integer, right? So each hypotenuse is the square root of of the next consecutive positive integer, like starting from square root of 2, not from 1. So square root of 2 is this, and you can also say that this is square root of 1, and then and it is like a hypotenuse of such a right angle triangle whose legs or perpendicular or base are of 0 length. So we cannot make that. So you can say that you can count this as a square root of 1. So we are starting from the first positive integer, square root of 1, square root of 2, square root of 3, square root 4, root 5, root 6, root 7, root 8, root 9, root 10, and then it keeps going on. So so not all of these hypotenuses represent irrational numbers. Some of them give you rational numbers, as in this case, square root of 4 equals 2, square root of 9 equals 3, and you will get square root of 16 equals 4. Okay, so there are some hypotenuses which will produce rational numbers, but after all, most of them are irrationals. Okay, so this is a good activity which helps you visualize irrational numbers in a better way, and it is also the application of the concept of irrational numbers and what we studied in our previous video about how to locate irrational numbers on a number line. So this is basically that effective use of that concept. Okay, so this is pretty simple, nothing much in here. If you do not understand anything in this, then do tell me in the comment box, and I'll try to cover that up in next videos. So that's for today. See you next class.